Hi friends, my name is Sandeep Singh and we'll discuss Junos operating system fundamentals. Junos OS functionality is segregated into multiple software processes. Each process handles a portion of device functionality. Each process runs its own protected memory space, ensuring that one process cannot directly interfere with another. When a single process fails, the entire system does not necessarily fail. This modality also ensures that new feature can be added with less likelihood of breaking current functionality. The Junos OS, the trusted secure network operating system powering the high-performance network infrastructure offered by Juniper Network. The Junos kernel is based on free BSD Unix operating system, which is an open source software system. As you can see in this diagram, Junos is the base operating system and everything is running on this operating system. Here, these are the modules. If one module will fail, the entire device will not fail. Another very good aspect of Juniper operating system is single source code base. All platforms running the Junos OS use the same software source code base within their platform specific image. The design ensured that core features work in consistent manner across all platforms running the Junos OS because many features and services are configured and managed the same way. The setup, task, and ongoing maintenance and operation within your network are simplified. As you can see in this diagram, whether you are using J2320 or TX matrix, setup command will remain same. So this is the benefit of using Junos operating system. Another aspect of Junos modularity is the separation of control plane and forwarding of data plane. The process that control routing and switching protocol are cleanly separated from the process that forward frame, packet, or both through the device running the Junos OS. This design allows you to tune each process for maximum performance and reliability. The separation of the control and forwarding plane is one of the key reasons why the Junos OS can support many different platforms from common code base. The graphic illustrates a basic view of the Junos architecture and highlight the control and forwarding plane. The control plane shown above the dashed line on the graphic run on the routing engine. The RE is the brain of the platform. It is responsible for performing protocol update and system management. The RE runs various protocol and management software processes that reside inside a protected memory environment. The RE is based on x86 PowerPC architecture, depending on the specific platform running the Junos OS. The RE maintains the routing table, bridging table, primary forwarding table, and connect to the PFE through an internal link. Although all Junos devices share this common design goal, the actual components that make up the control and forwarding plane vary between the different Junos devices. The PFE shown below the dashed line on the graphic usually run on separate hardware, and it's responsible for forwarding transit traffic through the device. In many platforms running the Junos OS, the PFE uses application-specific integrated circuit for increased performance because this architecture separates control operation such as protocol update, system management from forwarding operation. Platform running the Junos OS can deliver superior performance and highly reliable deterministic operation. The PFE received the forwarding table from the RE by means of internal link. FT updates are highly priority for the Junos OS kernel and are performed incrementally. Because the RE provides the intelligence side of the equation, the PFE can simply perform as it is instructed, that is forward frame, packet, or both. With high degree of stability and deterministic performance, this architectural design goal make possible the incorporation of high availability Feature like graceful routing engine switchover, non-stop active routing, and unified service software upgrade. In this graphic, you can see the RE handle all protocol process in addition to software process that control the device interface, the chassis component system management, and user access to the device. These software processes run top of the Junos kernel, which interact with the PFE. The software direct all protocol traffic from the network to the RE for the required processing. It also control and monitor chassis. The RE provide the CLI in addition to the JWeb GUI. The user interface run on top of the Junos kernel and provide user access and control of the device. Manage packet forwarding engine also. The RE control the PFE by providing accurate, up-to-date layer 2, layer 3 forwarding table, and by downloading microcode and managing software processes that reside the PFE microcode. The RE receive hardware and environmental status message from the PFE and act upon them as appropriate. The PFE is the central processing component of the forwarding plane. The PFE systematically forward traffic based on its local copy of the forwarding table. The PFE forwarding table is synchronized copy of the information created on and provided by the RE. Storing and using a local copy of the forwarding table allow the PFE to forward traffic more efficiently and eliminates the need to consult the RE each time a packet need to travel. PFE forward traffic more efficiently and eliminates the need to consult RE each time a packet need to be processed. Using this local copy of the forwarding table also allow platform running the Junos OS to continue forwarding traffic during control plane instability. It's also responsible for implementing service. In addition to forwarding traffic, the PFE also implement a number of advanced services. Some example of advanced services implemented through the PFE, including Policer, that provide rate limiting, stateless firewall filter, and class of service. Other services are available through a special interface card that you can add to PFE complex. Next is transit traffic. Transit traffic consists all of traffic that enter in ingress network port, is compared against the forwarding table entries, and is finally forwarded out an egress network port towards destination. A forwarding table entry for destination must exist for device running the Junos OS to successfully forward transit traffic to the destination. Transit traffic passes through the forwarding plane only and is never sent to the process by the control plane. By processing transit traffic through the forwarding plane, only platform running the Junos OS can achieve predictable high performance rate. Transit traffic can both unicast, multicast. Unicast traffic enter one ingress port and it's transmitted out exactly one egress port towards destination. Although multicast transit traffic also enter the transit device through a single ingress port, it can be replicated and sent out multiple egress port depending on the number of multicast receivers and the network environment. Next is exception traffic. Unlike transit traffic, exception traffic does not pass through the local device but rather requires some form of special handling. Example of exception traffic include the following: packet addressed to the chassis such as routing protocol updates, telnet sessions, ping, trace route, and replies to traffic source from the RE. IP packet with the IP option field in the packet. IP header are rarely seen, but the PFE was purposely designed not to handle IP option. Packet with IP option must be sent to RE for processing. Then last is traffic that requires the generation of ICMP messages. ICMP messages are sent to the packet source to report various error conditions and to respond to ping requests. Example of ICMP error include destination unreachable message, which are sent when no entry is present in the forwarding table for the packet destination address, and time to live expired message, which are sent when a packet TTL is decremented to 0. In most cases, PFE process handle the generation of ICMP message. The Junos OS send all exception traffic destined for RE over the internal link that connect the control and forwarding plane. The Junos OS rate limit exception traffic traversing the interlink to protect the RE from denial of service attack. During time of congestion, the Junos OS give preference to the local and control traffic destined for the RE. The built-in rate limit is not configurable. So this is the Junos architecture. Thank you for watching this video. I hope you have enjoyed it.